All right, so this video will focus on 6.1. And the first thing we're going to do is go through and solve these equations. Now, I want to highlight the fact that these are equations and they are not functions. We'll be talking about functions today. But the reason why these are not functions, just so you know, is I don't have two different variables. I only have one. So these are considered equations. So we're going to solve them algebraically. I'll give you a moment to do that. All right, so here are the answers. So x equals 11.4, negative 11 and 1/4, 7.34 or 7 34 hundredths, negative 7 and a fourth, negative 26 and a fourth, and finally negative 3/5. So how could you use mapping a diagram to show the relationship between two data sets? So if I look here, here's what I want to do. I want to go through and I want to say if I put an input in, meaning x equals 1, what does your output or your area equal? So if I'm doing area, which we know of course is length times width, right? So let's do that here. So L times W. And if I have like 2 times 1, I get 2. If I have 2 times 2, I will have 4. If I have 3 times 2, I have 6. And then finally, 4 times 2 is 8. So this is how you map them out. We're used to seeing the ordered pairs, which is like 1, 2, 2, 4, and so on. But this is a way that you map it. So if I put an input in, what is my output that I receive? So let's look at this one here. I look at circumference, and I know circumference is 2 times pi times r. So in this case, it would be 1 times 2, which is 2, and then times pi. So it'll be 2 pi. Next one would be if I plug in a 2 for radius, I'd have 4 pi. If I plug in a 3, I have 6 pi. And then finally, if I have 4, I have 8 pi. So again, the ordered pairs that I'd have, which would look kind of strange, but it would be 1, and then 2 pi, and then 2, and 4 pi, and so on. So I could interchange this, meaning I could go from an ordered pair and put it into a map, or I can map it out and then change it to an ordered pair. So here are the answers that we just saw a moment ago. There was a volume one as well I did not do. Sorry, it's down here. So if I plug in a 1, so 1 times 3 times 3 is 9, 2 times 3 is 6, times 3 is 18, and so on. And as we go through, I have the various answers right here. So make sure to come back and look at these and make sure that this makes sense to you. For this one here, I have my input and then my output. We have to try to figure out what's going on here. So 1 times something equals 8, but then 2 times something will equal 10, and so on. So if I keep on going here and I think about what I have to put in, like maybe it's going up by 2 every time, right? And so if I go to 0, I would have a 6. So perhaps this equation would be y, or in this case m, equals 2t plus 6. Let's just see if that works. So 1 times 2 is 2, plus 6 is 8. 2 times 2 is 4, plus 6 is 10. 3 times 2 is 6, plus 6 is 12. 4 times 2 is 8, plus 6 is 14, and so on. So I can do this a couple ways. And then this one here, it's 1 and 4/3, then 2 and 5/3. This is actually 6/3, isn't it? It's the same thing. So if I go up, it's just like 7/3, 8/3, 9/3, which is 3, 10/3. So that's pretty easy to do. So then it says complete this map and describe what's happening each time. So in this case, it's going up by 2, right? So I'll say it's 2. Oh, I'm sorry. So it's 8 and it's 10. So this would be plus 2 every time. And this is plus 1. So what we're basically doing is taking the relations or pairs of inputs with outputs. Okay, so a relation can be represented by ordered pairs or mapping diagram. These mean exactly the same thing as I said before. So if I look here, let's look at the ordered pairs. So I'm going to have like 1, 3, and then 2, 6, and 3, 9, and 4, 12. On this one I have 0, 0, 2, 1, 2, -2, and 4, -3. Guess it won't go through, but that's what it will be. And here they are. For this one, it says list ordered pairs. So I have 0, 12, 2, 10, 4, 8, 6, 6. This one here, I'll have 1, -1, 1, -2, 2, -3, and 2, -4. So we have to determine if it's a function or not. Now, in order to be considered a function, just so you know, I have an input has one unique output. So if I look here, this input has one unique output. This input has one unique output. This 5 has one unique output, and this 12 has one unique output. This right here would represent a function because there's only, it's a 12, like this 12 is just going to this 10. It's a 1-to-1 correspondence. So one output, so the ratio is a function. If I look at this one has one output, but this 0 has 2. And since it has 2 different ones, it is not considered a function. It's impossible. So it has 2 outputs, so the relation is not a function. So first of all, is this a function? It has a 1-to-1 correspondence. That's good. It's going up by 15 each time. And this is the inputs are going up by 1. This one here to determine whether the relation is a function. If I look here, this input has 2 outputs, right? So this is not a function. This one has a 1-to-1 correspondence, so it is a function. And then describe the pattern of inputs and outputs mapping on your own for this number 4. So it looks as though this is going down by 3, and this side's going up by 2. So this is not a function, like I said, it is a function. As the input increases by 2, the output decreases by 3. So kind of what we said before. And then finally you have your homework, and that